Hello everyone. So in this lecture we will be doing MCQs from the exemplar of the chapter integration. So let's start with our first question. So in this question we are given this integral cos 2 theta cos 2x minus cos 2 theta divided by cos x minus cos theta into dx. So to do this question, you can use the formula for cos 2x. So it has three formulas. Cos square x minus sin square x या फिर 2 cos square x minus 1 या फिर 1 minus 2 sin square x. So we will be using the second formula because the question is in terms of cos theta. So if we put the formula in, so we get 2 cos square x minus 1 minus 2 cos square theta minus 1. So 1 and 1 cancels and 2 can be taken common. So 1 and 1 cancels and 2 can be taken common and numerator में बचेगा cos square x minus cos square theta divided by cos x minus cos theta. So we can factorize the numerator and cancel cos x minus cos theta. And we get integral as twice of cos x plus cos theta. So theta is some constant, right? So cos theta is a constant. We will treat it as a constant. And this integral now becomes, so 2 cos x का integration cos x dx plus 2 cos theta outside because it's just a constant and dx का integration. So cos x has an integration of sin x and dx has the integration of x. So this becomes 2x cos theta plus some arbitrary constant c, and we can take 2 common to say the answer is sin x twice of sin x plus x cos theta plus c. So that makes option A as the correct option. Okay, so now let's move to our next problem. Okay, so in this problem, let's calculate first. So this looks like a question from NCERT. We'll proceed it as the NCERT approached it. So we'll find the difference between these two angles. So x minus a में से हम subtract करके देखेंगे x minus b, what is the angle? So this comes out to be x cancels and b minus a. Okay, and in case in denominator में अगर cos या फिर sin आता है, then we divide by sin of the difference of the angle, and if we have the alternate terms like sin and cos and sin, in that case we multiply and divide by cos of the difference of angle. So in this question we will multiply and divide by sin of the difference of these angles. So sin of b minus a, so which is just a constant, so I will keep it outside and I'll keep it inside also. So b minus a divided by sin of x minus a into sin of x minus b dx. So we already know b minus a is nothing but x minus a minus में x minus b. So we'll do that in the numerator and this integral will become 1 by sin of b minus a, and numerator में I can write sin of x minus a minus x minus b, sin of x minus a into sin of x minus b dx. Let's open up the numerator. So we will apply sin of a minus b. So sin of a minus b, which is sin a cos b minus cos a sin b. So let's see. So sin of b minus a, and we have sin of x minus a into cos of x minus b negative sign and cos of x minus a divided by, so into sine of x minus b divided by sine of x minus a into sine of x minus b dx. So let's divide the denominator with the both of the terms which are in the numerator. So okay, so we get 1 by sine of b minus a into integral of, so first term will become, तो यहाँ पे sin x minus a cancel हो जाएगा, we'll get cot of x minus b, and in the second term sin of x minus b will cancel and we'll get cot of x minus a. So all we have to do now is integrate cot x. So what is the integral of cot x? So if you remember the formula, cot x का इंटीग्रेशन होता है log mod cosec x बट नेगेटिव साइन के साथ, or you can say log mod sin x. So let's use the let's see the options कि वहाँ पे option में sin x के term में given है cosec, so it is given in terms of sin, so we will use the second formula. So let's complete this and we get sine of b minus a, and let's say integration we have done, and cot of x minus b का integration is log mod sine of x minus b and minus log mod sine of x minus a plus some arbitrary constant. So we can use the property of log and divide these terms and we get 1 by sine of b minus a into log of sine x minus b divided by sine x minus a plus c. So this 1 by sine outside can be also written as cosec. So let's check which option is correct now. So yes, cosec b minus a and ऊपर x minus b and नीचे x minus a. So it makes option C correct. Okay. As you can see, we can, so I'll write the answer here also. So you can write it as cosec b minus a into log of sine x minus b by sine of x minus a. Okay. So let's move to our next problem. Okay, so in this question we have to do the integration using by parts. So let's take tan inverse root x outside and we'll do integration of dx. So 1, basically we'll write it into 1, right? Okay. So and minus ddx of the term we took outside, which is tan inverse root x, integral of dx and whole thing in a bracket into dx. So which is tan inverse root x into x minus differentiation of tan inverse root x, which is 1 by 1 plus term inside squared, so which is x, into root x ka differentiation, which is 1 by 2 root x into dx ka integration, which is x, and whole thing in the bracket into dx. So this is x tan inverse root x minus, let's take half outside and we have root x से ऊपर वाला x cancel हो गया and we get root x in the numerator and divided by 1 plus x dx. So how can we solve this problem now? So probably we can use a substitution. Let me call this integral as I. So I'll say I is integral of root x divided by 1 plus x dx. So let's do a substitution. X is equal to t square. So dx will be equal to 2t dt and this integral I will become, so numerator में root x है which is t, and dx की जगह आएगा 2t dt, and denominator में 1 plus x 1 plus t square बन जाएगा, right? And our integral becomes, so 2 outside, t square by 1 plus t square dt. To solve this problem, so I will add 1 and subtract 1 in the numerator. So if it's not visible, I'll just bring the screen a little bit down. Okay. So, and now I have two integrals. So let me draw an arrow here, and now I have two integrals. I is twice of, so 1 plus t square and 1 plus t square cancel हो गया. So only term left is 1 into dt, and then minus twice of 1 by 1 plus t square dt. So this is I is twice of t minus twice of tan inverse t. Okay, so let's put back the value of t. So t is root x, so I is twice of root x minus twice of tan inverse root x. So let's put the value of I here, so which is this term, right? Okay. So now let's change the color of the pen, and we can say this integral now becomes x tan inverse root x minus half times, so twice of root x minus twice of tan inverse root x plus some arbitrary constant. So 2 cancel हो गया, and we get x tan inverse root x minus root x plus tan inverse root x plus c. So tan inverse root x common ले लेते हैं first and third term से, and we get into 1 plus x, so x plus 1, right? Okay, minus root x plus c. So let's check our options for this question. So looks like option A is correct, right? Okay, so option A is our correct option. So now let's move to our next problem. Okay, so let's write this integral and open up the numerator. So this is e की power x, and नीचे है 1 plus x squared whole squared, and ऊपर वाले को open करेंगे, we'll get 1 plus x square minus 2x, okay, into dx. So let's split the numerator up and write two integrals. So e की power x, and first term is 1 plus x square divided by 1 plus x square whole squared minus twice of x divided by 1 plus x squared whole squared, and this simplifies to e की power x 1 by 1 plus x square minus 2x divided by 1 plus x square. So this is a question basically from NCERT. So and we have a formula also for this, e की power x into fx plus f dash x into dx. This integral is nothing but e की power x into fx plus c. So now let's just check if I take my fx, if I take my fx to be 1 by 1 plus x square, let's differentiate this to check if the second term is the derivative or not, right? F dash x is, let's apply the quotient rule. So 1 ka derivative 0 into term in the denominator, then negative sign 1 remains same, 1 plus x square ka differentiation 2x divided by 1 plus x square whole squared, so denominator squared, and which is minus 2x divided by 1 plus x square whole square. Okay, so this is fx and this term is f dash x, and I can say the result for this question is e की power x into fx, which is 1 by 1 plus x square plus c, and that makes option A correct, right? Yeah, so ऑप्शन ए is correct. So NCERT में solution में शायद C दिया हुआ है, which is wrong, right? So as you can see, so option A is the correct one. So let's move to our next problem now. Okay. Okay, so our next problem is integrate x की power 9 divided by 4x square plus 1 की power 6 dx. So right now I cannot see too many substitutions, but in such questions it's always a good idea take the highest power common from the denominator जो ब्रैकेट में हो. सो वी विल टेक यहाँ पे अंदर 4x² प्लस 1 में से हाईएस्ट पावर इज x², वी विल टेक x² कॉमन. तो x की पावर 9, इफ आई टेक x² कॉमन बाहर क्या आएगा, x² की पावर 6 विच इज x की पावर 12, एंड इनसाइड आई विल बी लेफ्ट विद 4 प्लस 1 बाय x², तो पावर 6, राइट. ठीक है, so this question becomes 1 by x cube and 4 plus 1 by x square की power x squared की power 6 dx. So we all know 1 by x square का differentiation will be 1 by x cube type. So I'll take that as a substitution. So let's say 4 plus 1 by x square is z. So इसका differentiation will be minus 2 by x cube is dz by dx. So into dx is dz, and I can find the value of 1 by x cube into dx. It is minus half dz. Okay, so 1 by x cube into dx is minus half into dz, and the other terms are 1. तो ये पूरा टर्म क्या बन गया, z and उसके power 6, right? ठीक है, but that's in the denominator. So let's solve this question further. So we have z की power minus 7, so sorry, minus 6 का integral है, right? So this is z की power minus 5 आएगा, so minus 6 plus 1, so minus 5 divided by minus 5 plus c, so minus minus plus, and this is 1 by 10, and नीचे क्या आ रहा है, z की power 5 plus c. But what is z? Z is 4 plus 1 by x square, so which implies 1 by 10 of 4 plus 1 by x. So that's in the denominator. So you can say z की power minus 5 also, right? So I'm using this one, right? So 4 plus 1 by x square की power 5 plus c, and this is 1 by 10 4 plus 1 by x square to the power minus 5 plus c. So let's check which option is correct. So looks like option D is the correct option, right? So okay, so let's now move to our next problem. Okay, so in this question we have an integral 1 by x plus 2 into x square plus 1 dx, and we have to find the value of a and b. So either you can differentiate the right hand side and compare the coefficients by taking the LCM, or you can just solve it normally using partial fractions. I will use partial fractions. So 1 by x plus 2 into x square plus 1 में अगर हम partial fraction use करेंगे, so x square plus 1 is not factorizable, so I have to write 1 a by x plus 2. तो ऊपर क्या आएगा, linear term यहाँ पे bx plus c divided by the quadratic term x square plus 1 which is not factorizable. Okay, let's take the LCM and compare the coefficient. So a times x square plus 1 plus bx plus c times x plus 2 must be equal to 1. So comparing the coefficients now, so let's simplify the RHS a little bit more. So this is ax square plus a plus bx square plus 2bx plus cx plus 2c. Okay, now I can compare the coefficients. X square का coefficient compare करें, left side पे 0 है, right side पे I have two coefficients a and b, so a plus b. X का coefficient left side पे 0 है, right side पे x का coefficient is 2b plus c, and constant coefficient is 1 on the left side, and right side पे it is a plus 2c. So let's solve these equations and eliminate some variables. Let's see. Um, let's see from I can double the first equation. So 2a plus 2b is 0, and I already know 2b plus c is 0. So I subtract these two to find the relation between a and c, so which says 2a minus c is 0. Okay, so I will double this equation to eliminate a. So I will say 2a plus 4c is, so I'm multiplying this equation with 2, is this is equal to 2. So I subtract again to find minus 5 minus 5c is minus 2, and c is 2 by 5. Let's find the coefficient b now. So अच्छा c निकाल लेते हैं, we already know c, अच्छा c पता चल गया, so a निकाल लेते हैं. We know 2a minus, so c is 2a, ठीक है, so we already know 2a minus c is 0, so a is half c, half times 2 by 5, so we find a is 1 by 5, and अब a पता चल गया, c पता चल गया, let's find b. A plus b is 0, so b is minus a, which is minus 1 by 5. Okay, so now I have the partial fraction, so I can say now this integral can now be written as a, so which is 2 by 5, I think, right? Sorry, 1 by 5, 1 by 5 divided by x plus 2 plus bx plus c. So b is minus 1 by 5 and c is 2 by 5. So minus 1 by 5x plus 2 by 5 divided by x square plus 1. So this is our partial fraction into dx. So I have 1 by 5 into 1 by x plus 2 का integral, and then in the second one I'll just separate both of, I'll write the two integrals. पहले वाले में I'll take x वाला term, I'll take minus 1 by 5 outside, and I'll write x by x square plus 1 dx, and then I'll take 2 by 5 outside and 1 by x square plus 1 dx. In the second integral I'll multiply and divide by 2. So x square plus 1 का differentiation 2x होता है, this will be the logarithmic term, and our equation simplifies to 1 by 5 log mod x plus 2 minus 1 by 10 log mod x square plus 1 plus 2 by 5 tan inverse x plus c, which is our integral. So now let's compare our answer. So this is question number 53. So by comparison, 1 plus x square के साथ में यहाँ पे you can see is small a, and that is minus 1 by 10. So a is minus 1 by 10. So option A or C might be correct. And then B is with tan inverse x. Tan inverse x के साथ में 2 by 5 है, so that makes option C correct. Okay. So by comparing it with this answer, our result with this answer, we get option C as the correct one. So let's move to our next problem. Okay, so in this problem, let's see. तो ऊपर न्यूमरेटर में पावर ज़्यादा है तो विल डू लॉन्ग डिविजन फर्स्ट. तो x प्लस वन से हम डिवाइड करेंगे x क्यूब को. देन लेट्स से x स्क्वायर, आई विल गेट x क्यूब प्लस x स्क्वायर. सब्ट्रैक्ट किया so these two cancel, so this is minus x square. Then I will multiply with minus x to get minus x square here and minus x here, so plus and plus, so these two cancels, and then I get x. So I'll multiply with 1, so I'll add 1 here, so this is x plus 1, and minus, so these two cancel, the remainder is minus 1. Okay, uh, so I can write dividend is equal to divisor into quotient plus remainder. So x cube can be written as now x plus 1 into x square minus x plus 1 minus 1 and divided by x plus 1. So I'll write so हमारा पहला इंटीग्रल बन जाएगा x square minus x plus 1 कैंसिल हो गया, माइनस में 1 by x plus 1, right? Okay, these are all the four terms that we have to integrate. So our result is x cube by 3 minus x square by 2 plus x minus log mod x plus 1 plus c. So let's compare it with our options. So plus x, okay, plus x हर जगह है, minus x square by 2, it's in नीचे वाले दो options में, plus x cube by 3, okay, so option D, right? Okay, option D is the correct one. So let's now move to our next problem. Okay, so in this problem it might look like you can take x plus sin x as z, and but 1 plus cos x should be in the numerator to do that, right? X plus sin x का differentiation is 1 plus cos x, but it should be in the numerator if you want to do that substitution. But this is a different question, so I'll mark it important. So to do this question you have to separate these out. तो पहला integral बन जाएगा x by 1 plus cos x, and the second integral is plus sin x by 1 plus cos x. And in both of these you will use half angle formula. So x divided by 2 cos square x by 2 dx, and this is 2 sin x by 2 into cos x by 2 divided by 2 cos square x by 2. So in the second integral 2 cancels and cos x by 2 cancels. So I have half outside, x times secant square x by 2 dx plus integral of tan x by 2. ठीक है, सेकेंड इंटीग्रल तो हो जाएगा. लेट्स अप्लाई बाय पार्ट्स इन द फर्स्ट इंटीग्रल, राइट? इसको बाय पार्ट से ही करना पड़ेगा. So if you use I8, so you have a algebraic term which is x, and you have a trigonometric term which is secant square x by 2. So we'll take the difficult term outside which is x. So यहाँ पे I8 अप्लाई करेंगे. So let's use a bracket. So x outside, integration of secant square x by 2 dx minus integral of d dx of x integral of secant square x by 2 dx whole bracket dx and plus integral of tan x by 2, which we know it's simple one, right? So half, so this is x, and secant square x by 2 का integration will be tan x by 2 but divided by half, right? So minus 1 into again tan x by 2 divided by half dx. Okay, so it looks like हमें tan x by 2 दो बार integrate करना है. So I'll just simplify it first कि let's find शायद वो cancel हो जाए because it's a 1 mark question. Otherwise tan x by 2 can be also integrated. So यहाँ पे this 2 and this 2 cancel, we get x into tan x by 2, and then this 2 and this 2 cancel, and this is minus integral of tan x by 2 dx, and this is plus integral of tan x by 2. So if you want to, you can integrate that and cancel it later, but I'll just cancel them right now without integrating, plus some arbitrary constant. So our result is x tan x by 2 plus c. So which option is that? So let's check that. So this is 55th question, and x tan x by 2 plus c is option D. Okay, so now we can move to our next problem. Okay, so now we have a new problem. We have to integrate x cube divided by 1 plus x square root के अंदर dx. So like most of the books, you can use this substitution. Maybe 1 plus x square is equal to t square, and then you can put 2x dx is 2t dt, and x dx will be nothing but t dt. So your integral, which is x square into x dx divided by square root of 1 plus x square, will now transform into, तो x square की value आ जाएगी t square minus 1, x dx is t dt, and divided by square root of t square, which is t, and then you can solve this question as t square dt minus integration of dt plus c, and this is t cube by 3 minus t plus c, and t की वैल्यू डालेंगे. So t is square root of 1 plus x square, so square root of 1 plus x square the whole cube divided by 3 minus square root of 1 plus x square plus c, and by comparing coefficients we can find a is 1 by 3 and b is minus 1. So option D is correct. Alternatively, you can stick to your basic method than these substitutions. So basic method is like, if you ever have a square plus x square, use x is equal to a tan theta as the substitution. If you have a square minus x square, use x is equal to a sine theta as the substitution. And if you have x square minus a square, use x is equal to a secant theta as the substitution. So in this case, I will use x is equal to tan theta as the substitution. So let's try method 2. So in this method 2, I will use, क्योंकि मेरे पास denominator में क्या है, so I have this integral, right? X cube divided by square root of 1 plus x square. So a square plus x square type of term, so I'll use x is equal to tan theta as my substitution. I'll do the question using this. So I can find dx is nothing but secant square theta d theta, and I will do a trigonometric integration rather than algebraic. So this question will change into tan cube theta into dx की जगह secant square theta d theta, and नीचे 1 plus x square will become 1 plus tan square, so which is secant square theta inside the square root. So our question changes to tan cube theta into secant theta d theta. Okay, so secant square नहीं आ रहा, secant theta आ रहा numerator में, but we already know कि ddx of secant theta is secant theta tan theta, right? So I'll use that to our advantage. So I'll use secant theta as the substitution. So to do that, let's split that into tan square theta into secant theta tan theta d theta. And this tan square theta can be written as secant square theta minus 1. So secant square theta minus 1 into secant theta tan theta d theta. So first integral will become secant square theta into secant theta tan theta d theta. minus secant theta tan theta d theta. So okay, so in the first integral you can put secant theta. So you can put secant theta is equal to z. So secant theta into tan theta d theta will be dz, and this will become z square dz, and this will be z cube by 3. And this integral we already know, this is minus secant theta, right? So secant theta tan theta का integration is secant theta. So plus c, so minus secant theta plus c. So simplifying it further, so z की value क्या थी, secant cube theta, right? Secant cube theta by 3 minus secant theta plus c. But हमारा question was in terms of x, and we have used a substitution. Our substitution was x is equal to tan theta. So let's find the value of secant theta from this. We already know secant theta is nothing but square root of 1 plus tan square theta. So it is square root of 1 plus x square. So this result will change and it will become 1 plus x square का square root की power 3, which is power 3 by 2, and 1/3 of that, right? ठीक है, minus 1 plus x square root के अंदर plus c. And this is the alternate way to solve the same problem, and we get the same result, which is option D. Okay, so now let's move to our next problem. Okay, so this looks like a very simple problem. Our integral, which is minus pi by 4 to pi by 4. So 1 plus cos 2x can be written as 2 cos square x, right? Okay. So you can take half outside, and cos square x can go to the numerator. It will become secant square x. And you can see that this is an even function, right? For even functions, the integral will become double, and we'll do from minus a to a. Integral can be written twice of 0 to a, right? Okay, so this will become 0 to pi by 4 secant square x dx, and I'll just double it, right? Okay, so now I'll cancel the 2. So this integral now is secant square x का integration क्या होता है? Well, it is tan x, and the limits are 0 to pi by 4. The answer is tan pi by 4 minus tan 0, which is 1 minus 0, and which is 1, right? Which makes option A correct. A very, very easy question. Now let's move to our next problem. Okay, so in this problem we can let's see, maybe uh, simplify 1 plus 1 minus sine 2x as, so let's do it on the right side. 1 minus sine 2x can be written as 1 minus 2 sine x cos x, and 1 can be written as cos square x plus sine square x. And we have the square root also, right? So the square root of this is cos x minus sine x whole squared plus just remember कि square root of x square is mod x, so result is mod of cos x minus sine x. Okay, so our integral now changes. It becomes 0 to pi by 2 mod of cos x minus sine x dx. So either you can find कि कहाँ पे ये 0 आ रहा है, so 0 will be at pi by 4 and it is changing sign. So either method 1 can be, you can do the integral 0 to pi by 4 जहाँ पे and then you can split it at pi by 4 to pi by 4 to pi by 2, and pi by 4 तक cos x बड़ा होता, right? So if you see the graphs cos x and sin x का, this is pi by 2, let's say, and this is sin x, right? So and they meet at x is equal to pi by 4. So pi by 4 तक cos x ऊपर होता है, right? ठीक है, and sin x नीचे होता है. So cos x minus sin x is positive, so you can write cos x minus sin x dx, and then value will be minus sin x plus cos x, basically sin x minus cos x, because after pi by 4 sin x is positive, right? Sin x minus cos x is positive, you have to multiply with negative. So this could be method 1 to do this question. Method 2 can be so method 2, let's put some space here. Okay, so I'll just write method 2. Method 2 के लिए you can take your fx as mod of cos x minus sin x, and you can calculate f of 2a minus x. So, and I'm using the integral 0 to 2a fx dx is twice of 0 to a fx dx when f of 2a minus x is equal to fx, right? So let's see if I can use that. So f of 2a minus x, our integral is going from 0 to pi by 2. So, so this is our 2a is pi by 2. So this is f of pi by 2 minus x. And this is mod of cos of pi by 2 minus x minus sine of pi by 2 minus x. And this is mod of sin x minus cos x, and which is same as mod of cos x minus sin x, right? So I can use maybe a method 2. So from method 2, so this will be of course a little bit longer, not that much, right? Because question almost ho chuka, right? You have to just integrate and put the value. So from method 2, you can do twice of 0 to pi by 4 and mod of cos x minus sin x. And we already know 0 to pi by 4 में cos x minus sin x positive होता है, right? We have just shown it from the graph. So I can remove the modulus very easily. So this integral will become twice of 0 to pi by 4 cos x dx minus twice of sin x. So integral of sin x dx 0 to pi by 4. So this is twice of sin x 0 to pi by 4, and sin x का integration minus cos x, so plus 2 cos x 0 to pi by 4. So this is 1 by root 2 minus 0 plus twice of 1 by root 2 minus 1. So this is root 2 plus root 2 minus 2. This is 2 root 2 minus 2. So basically you can take 2 common, root 2 minus 1. So let's check an option which is this 2 root 2 minus 1. So twice of root 2 minus 1 is option D. Okay. So now let's move to our next problem. So hopefully you're enjoying this. So notes are below. Okay, so looks like we have a simple question. So 0 to pi by 2 cos x into e की power sin x dx. So e की power x I can integrate, not e की power sin x, and sin x का differentiation cos x होता है, which is available. So we'll take it as a substitution. Let's say sin x is equal to t. So cos x is dt by dx. So cos x into dx is dt. And then you can find the value of t. So when x is 0, t is sine 0, which is 0. And when x is pi by 4, sorry, pi by 2, t is sine pi by 2, which is 1. Okay, our limits changes from 0 to 1. Cos x into dx is dt, and e की power sin x will become e की power t. So this integral is e की power t, and limits are 0 to 1. And the answer is e की power 1 minus e की power 0, which is e minus 1. which, so e minus 1, so which okay, so let's fill in this blank. So e minus 1 is the answer, same as the book. So let's move to our next problem. Okay, again we have a very simple problem. So we have e ki power x into x plus 3, which I will write x plus 4 minus 1 divided by x plus 4 square. And you can imagine what I'm trying to do here. I'm trying to use the formula e ki power x into fx plus f dash x into dx, is this integral is e ki power x into fx plus c. So I have two terms now. 1 by 1 by x 1 by x plus 4 minus 1 by uh, x plus 4 whole square dx. So let's take fx to be 1 by x plus 4. Its differentiation f dash x. So x की power minus 1 का differentiation is minus 1 outside and power minus 2. So this is minus 1 by x plus 4 whole square. So you can check that. And through all this, we have the answer for this question, which is e ki power x into 1 by x plus 4. Okay, so plus c, right? So this is equal to e ki power x divided by x plus 4 plus c. Okay, so let's move to our next problem. So again, we have a very simple problem. Let's see. So 0 to a, and let's make the coefficient of x square as 1. So let's take 4 outside. So this will become, let's say x square plus 1 by 4, right? Which is half square, right? And you can use the simple formula integration of 1 by x square plus a square, which is tan inverse x by 1 by a tan inverse x by. So this will be 1 by a. So a is half into tan inverse x by a. So this is 1 by 2 tan inverse. Okay, so I don't need to add c. The limits are there, which are 0 to a. So 2x 0 to a. And this is given equal to be pi by 8. तो हमें a की value निकालनी है. This is pi by 8. So let's solve this to find a. So let's put in the value. So half remains outside and x की जगह a डाला, tan inverse 2a minus tan inverse 0. So tan inverse 0 is 0, is pi by 8. So half cancel. I have tan inverse 2a is equal to pi by 4. 2a is tan pi by 4, which is 1. So I find a is equal to half. And the answer becomes 1 by 2. So now let's move to our next problem. So okay, so cos x का differentiation sin x होता है, so I'll use that. So in this question I'll use a substitution. Cos x is equal to t, so minus sin x into dx is dt. So sin x into dx is minus dt and integral will become minus dt, and denominator में क्या आएगा 3 plus 4 t square. Okay, so let's take 4 outside and make coefficient of t 1. So I will have 1 by 4 and let's say negative भी बाहर ले लिया. So I have t square plus 3 by 4 dt. So if it is not visible, I'll just go a little bit below, right? So and now I can change this integral. So this is 1 by t square plus root 3 by 2 square. So 1 by x square plus a square has the integral 1 by a tan inverse x by a. So this is 1 by root 3 by 2 into tan inverse t divided by root 3 by 2. But t was cos x. This is minus 1 by 2 root 3 tan inverse 2 by root 3 into t. T is cos x, right? Okay, so this question is also done and we can fill this blank also, right? that the answer for this question is minus 1 by 2 root 3 tan inverse 2 cos x divided by root 3 plus c. Okay, so now let's move to our last problem for this chapter. Okay, so we already know minus a to a fx dx can be 0 if fx is odd function, right? So and we look at this and we can see it's a odd function. So fx अगर हम assume कर लें sin cube x into cos square x, so f of minus x is sin cube minus x into cos square minus x. So cos of minus theta is cos theta. So this will remain here and this इसमें से minus बाहर जाएगा and cube है तो it will go outside, right? This is minus sin cube x into cos square x, which is minus of fx. So this function is a odd function, right? And the result for this question is 0. Okay, so hopefully you enjoyed this and the notes will be available below the video. So make sure to like, share and subscribe.